My name is Sumerjip. Here today, I'm with Jérôme Vildon and Christophe Dujarik. I pronounced it right, right? Yeah, okay. So I work for Blackfire company as a senior software engineer on the Python side, and Christophe works for chief product officer, and Jérôme works as developer advocate. And today I will try to explain something on hunting Python performance with Blackfire tools. So let's start. So the first thing I will say about profiling on Python and performance is that it's equal to measurement. So you cannot improve something you cannot measure, right? Measuring is key to that. And profilers are the applications to help on that kind of thing to us. And when I search for GitHub for Python profiler, for keyword Python profiler, I get this result. As you can see, there are over thousands of profilers available in the ecosystem. And I really would like to dig deeper a bit on what these tools provide for us, as well as Blackfire, what's the difference between them. So first, some basics. All these 1,000 profilers can be categorized into two types in the Python world. And the first one is tracing and the sampling profilers. Tracing profilers does measurements when certain events happening inside the interpreter, whereas sampling profilers work by sampling the call stacks of the profiled application at specific intervals and merging all the data all together to show you the output. There is a very basic trade-off between the two. While the tracing profiler can provide more metrics and more accurate data, the sampling profilers will optimize for speed and will have the smallest possible overhead. Yeah, both we can say that both have pros and cons to each other. Yeah, so in Python world, roughly we have three basic events happening inside the interpreter. The tracing profilers do measurements can make measurements on both function level, line level, and opcode level with Python 3.7 and up. Like every function is called, there is an event happening inside the interpreter, and you hook to that event and do some measurements. For every line, you do the same, and for every opcode, you can do the same, do some measurements and provide the output. Of course, the more you do the measurements, the more overhead you will have for the profiler. But yeah, we optimize for overhead, obviously. There is also the opcode profiling. I haven't yet seen any tool regarding that, but maybe someone will write that too. These sampling profilers, on the other hand, took another approach to optimize for overhead. As I said, as you can see from this image, it directly looks at the call stacks of the threads of your application and accumulate this information. And it does seem to not work at first, but given enough time, you start aggregating data, and you will end up with a pretty accurate view of what's happening inside your application. And there is also one distinction here, that internal and external. I put an I to underline that fact. So internal means that the sampling profiler runs inside your process, inside your profiled application, whereas external means that it runs as a separate process, and you give that separate process your process ID, and it will connect to that process, read its memory, and read its call stack, identify the call stack information, and aggregate them together. This is how it works. So, but we haven't talked about what these profilers measure yet, right? They measure time, obviously. but there are different flavors of time when it comes to computing. And the first one is, there are actually 3 types in especially Blackfire, and there are maybe 2. You can see everybody is talking like two types of time. The wall time is like profiling your code with a stopwatch on your wrist. Like you are looking at the time clock and in the wall. And the CPU time is actually total amount of time your CPU spent on your code, running your code, including the kernel time. And when you subtract the CPU time from the wall time, you will end up on how much time your code actually waited for input-output operations. And there are also more metrics you can measure, right? And memory is one of them. In Python world, I have seen 2 distinct implementations of memory profiler. Maybe I will talk a bit on them, but the trace malloc comes with the standard library, I think Python 3.4, and it works on malloc level to show you the unfreed bytes, whereas object graph works on Python object level and shows you all unfreed objects, and both have pros and cons to each other. And there are also some application-specific metrics like Django debug toolbar, and what it basically does is it's installed inside as a panel to your application, and you can look some metrics like how much time it took for my template to be rendered, or how much time it consumes for my SQL Django ORM SQL query to be executed, that kind of stuff. That's application-specific metrics. So I'd like to walk over some examples on the ecosystem that I showed previously to understand what these tools provide for us and what Blackfire provides too. And while preparing this list, I wanted to underline that I try to select profilers that are distinct in their feature set. So there might be profilers you maybe think that are better than this ones in this list, and you might be absolutely correct. But as I said, my motivation is to find the distinct feature set, minimum list of overlapping feature set. So the first one I'd like to talk about is the line profiler. So basically, line profiler, just as I said, it hooks into the interpreter for line events. It measures per line wall time. You can inspect its output from the CLI. What you see here in this example is that a function is being called and how much time this line actually executed, how much time it spent inside this line altogether. And it aggregates all the data, of course, during your profiling session. And the second one, I might be biased on this because I wrote this one. It's actually function tracing tool, and it measures per function, wall, and CPU time. You can profile multi-threaded applications, and you can show per thread statistics with it. And it can output key cache grind to visualize its output as a call graph you can see from the screenshot. The next one I'd like to talk about is the PySpy, which is a sampling profiler. It is an external sampling profiler, which means that you give a process ID, and it will connect to your application via process ID and dump its memory and aggregates the data altogether. It can measure, mostly sampling profilers measure CPU time, but there are some exceptions to that. It has minimal overhead, like 10 or 15%. It has a top-like CLI, which you can see on the runtime which function is being executed and that kind of stuff. And also it can output to flame graph or speed scope formats. I really encourage you to look at the flame graph format too. These profilers, it's in Blackfire we have similar thing. I will talk about it later. And tracemalloc is a memory profiler. It's in the standard library since Python 3.4. So basically what it does is once you enable the tracemalloc, it starts tracing all memory allocations. It can do it per line, per traceback, per file. Whenever you allocate an object, it will get a traceback at that place and use that traceback information to aggregate data based on line, traceback, or file. It has a CLI interface, and you can compare snapshots through its API. And finally, I'd like to talk a bit about Blackfire, of course. Blackfire is actually in a slightly different category in this sense, because it's a tracing profiler, it's not sampling profiler. So you basically can see whole picture. We are not sampling anything, but it's only enabled on demand. So this means that it's pretty safe for production usage. Whenever you are not profiling an endpoint, it's adding zero overhead. How it works is like, you can use some tools like Blackfire curl or a Chrome extension, or manually do something. It will inject a special HTTP header, for example, and it will enable the profiler for you. And from now on, that request, that specific HTTP request is being profiled, and the concurrent ones are not profiled at all. And they are profiled for wall time, CPU time, peak and used memory, and some application metrics that we have already defined for. And we also have all these dimensions all together in a web application that you can just click and go to. We output to call graph and timeline. And actually timeline is like, maybe you know it previously, it's very similar to flame graph, but it has also a time dimension. I will talk about it later. So yes, this is actually what I'd like to talk about for the presentation. So is there anything you'd like to add, Jerome or Chris? Is there anything you'd like to add?
I think you explained it perfectly.
Okay. So let's jump on the live demo then. Okay. So I'd like to show you, let me stop my share here and share my desktop. So I'm assuming you can see my screen, right?
Yes, we can.
Okay. So here I have a very basic Django application. So it's just, it has two views, and the first one will be this one. So what it basically does is it makes an HTTP request here, and then it retrieves some model from the database, comment objects all, and it sends it to the template, and that's all. And the model the comment model that we are retrieving from the database consists of two fields, which is the first one is comment, which is just char field, and the user is a model foreign key on the Django user model. So that's all, basically. So let's assume that we have some performance problem with this application, and we'd like to use Blackfire. So the first thing, of course, we will do the install Blackfire. So for installing Blackfire, it's just pip install Blackfire. It's on PyPy, of course. And when you do that, it's already installed, but yeah, it will be working. So when you do that, it will, of course, add it to side packages. And what you can, the next step you will do is to add it as a middleware here. So as you can see, this is the settings file of the Django application. And you will just enable the middleware as Blackfire middleware, Django middleware. And then we will just run the application. Okay. And when we will go to the page, you can see that it's just outputting the comments, and that's all. So we have actually a Chrome extension, this one here. We just click on it and click profile. When we do that, Blackfire, the profiler will just starts aggregating the data. Currently, it's making multiple requests to the page to average out the data. So maybe the first one is read from the cache, maybe something else happened. So it's making multiple requests to make sure that data is consistent. So okay, so when it finished, it presents you with this information here, and you can, as I told before, we have two kinds of visualizations, profile visualizations. One of them is timeline. I will talk about it later, and the call graph. So let's start with the call graph first. So this one, actually, this is the introduction, or the first page that that welcomes us in Blackfire. So it's the functions we have here. We have a call graph here, like that one. We can zoom in and zoom out, and we can click on tabs here. Yeah. So I will walk over these a little bit. So the first one that's open is the wall time. So, and we have also the IO time here, as we talked in the presentation, the CPU time here, and the peak memory. So all these dimensions have also one table here, on the left side, and one call graph view here. And for the table, I'd like to talk about a bit on inclusive and exclusive time. So here the first thing that you will notice is that we have a call number here, which is the call count of this function here. And the exclusive time and inclusive time. You can filter based on those functions, those properties, I'm sorry. And as you can see, for example, in this wall time, you can see that 8% of inclusive time has been spent for this function, which means that in total runtime of the application, which is 2 seconds, this function contributes 8% time to it. So it's the, as I said, it's the wall time. And you can also see the same with the call graph view here. So the call graph is actually consists more nodes than it can be seen here, but Blackfire just prunes that data out because some calls are seen as insignificant because of their runtime being so small compared to other functions. So what you will end up seeing here is actually the hot path, which is the critical path, hot path, or whatever you call it, but it's the most time consuming functions chained together, and you can see them as caller-callee pairs. So that's pretty nice. So if you come here, for example, you can see that our main function has been called, and then it calls the n+1 view, which is the code that I showed you here. And then it comes to Jinja template render. So inside that template, we call some functions, and it comes to query set API. And for example, it then goes to built-in LAN and fetch all, and moderatable, and SQL compiler execute SQL. So if you also come here, you can see that 30% of the inclusive time has been spent on this function, SQL compiler as SQL. So it seems like there's something happening. Like it's also it has been called 150 times, this function, this SQL compiler get select function. If you click that, you can see the details on that function. Django DB models, SQL compiler get select. So it seems like in the rendering code, there is some path that leads to this SQL compiler being called 150 times. And yeah, that's what we can see from the wall time here. Let's also look at a bit on the IO wait time. And you can also see IO wait time. The top exclusive function is the function SQLite wrapper, and it's the SQLite wrapper execute, right? And you can see that there are also some other functions related to SQL again. Like if we can maybe make it bigger, yeah, SQL query build filter or compilers as SQL. So there is something happening with the SQL statements being executed, and those are happening 150 times. So the same also happens with the CPU time. Actually, the CPU time is pretty close to wall time, which means that so this function is the dominant one. So which probably the performance problem is because of this function here. Because as you can see, it's taking the 30% of the runtime again, and it's again showing the SQL statement being the problem. So I will skip these ones for a little bit. Maybe I can talk about this one here. So you can also see your HTTP requests in Blackfire.io. So we instrument some application-specific metrics. So we currently instrument some HTTP client libraries. One of them is requests. So whenever I make this call here, request.get, to a dummy endpoint in my server, it's actually intercepted, and you can see them here, which is pretty nice because inside a single view, in a single view, you probably have more than one or two or three maybe REST API calls, and it would be nice to see them with call number and timing information. Maybe the performance problem was because of that endpoint, but in our case, it seems not, because it's so small. And we also, we come to here SQL queries. Normally with this code here, comment objects.all, I would expect to see only a single SQL query, but as you can see here, we have 150 SQL queries somehow occurring, right? And normally I would expect something like this one here, but we also have this one, which is just going to the out user table somehow and trying to retrieve something. So that's some kind of problematic. And we also have seen from the previous wall time investigation observation that it's coming inside render. So from just up to this point, we know that it's coming from render, and something is happening 150 times calling the out user table. And the last thing I would like to show you is the timeline. Timeline is actually my favorite. It really helps on finding your debugging complex performance problems, because it can show you the whole information, including the time information too. So for example, if you just click here and here, let me just make it greater. Yeah, you can see that you can zoom in and zoom out here. And if we just let's start for the first 500 milliseconds. So we are currently looking at the call stack of your application for the 500 milliseconds. So in this case, the most interesting one is this purple one here. You can see that we are making the dummy request here in the code. And then you can also see the Django template render is being called. And by the way, the top of here is the top of the call stack, and the bottom one here is the, let me just show it. Yeah, here is the top of the call stack. And if you click on it, you can see the call stack information in its entirety. So what you see here, the view is being called, and the view calls render function, and render calls somehow query set fetch all, and it calls SQL compiler get select somehow. And you can obviously see that there's some repetitive work is being happening, right? So after this point, inside the render function, you can obviously see a pattern, right? Something always happening. It's going to DB all the time, SQL. And after this point, we decided to look at the template code, which we probably should have done it earlier, but this is just for demo purposes. So and once we go to the template here, you can see that we are just iterating through the comments model and printing out the comment, like here. And we also have by admin. So this means that we are also printing out the user. So once we print out that user, as that user is the foreign key, Django ORM will do not have that data, right? It's directly saved into the comment object. So it will try to fetch that data. And that means that you will make SQL queries every time you iterate over this command. So it means that you will have SQL queries as much as how much comments you have. And this is called, this is a classical problem, as you might probably know. And this is called the N+1 problem. And the Django solution to that is, please correct me if I'm writing it wrong, but prefetch related, select related, I'm sorry. Yeah, select related is Django solution, right? So if you do that, what will happen is when Django ORM tries to generate this query set or converting it to SQL, it will prefetch the user foreign key from the database with a join, and it will eliminate the extra SQL queries, hopefully. So let's see what happened. Let's profile it again. Yeah, okay, you can see that our SQL query got a little bit complex, but with the inner join with the out user table, but it reduced to only being one. So that's pretty good optimization we have. And the runtime is optimized very much. But how much? To see how much really optimized, Blackfire also offers you to compare. So as I misclicked, it would be some problem. Yeah, I think that one is the problematic one, and this one was the fix. Yes. So with the comparison feature, I really like this one too. You can see whole dimensions, what kind of percentages you have optimized. So this is very helpful in situations even when you do some micro optimization. Suppose that you just micro optimize a single function call, and what you will see here is that how it contributes to the overall picture. As you can see, SQL queries has been optimized for. You can click them, and this one is gone. This one is new, and this one is gone as well, and that kind of stuff. When you click the function, you can see from which number it reduced to which number, and that kind of stuff. And yes, so I believe I have one more thing to show you, which is this one. Okay. So the second thing the last thing I'd like to show you is the memory profiler. I haven't talked about memory profiler yet. So let's assume that, so let's first start with some basics. Whenever a query set in Django executed, by default, it caches it, right? So when you retrieve the comment objects all here, and you just use comment or you just iterate over and over again, it will use it from the cache. It will not go back and retrieve it from the database. And that's for a reason, right? Because you mostly retrieve something from the database and use it more than once, probably. But if you really would like to optimize, let's assume that in this case, you would really like to optimize for memory, and you will have a memory problem. And let's profile this page. This page is it's pretty much the same, but without the. Let me show you yeah, it's just printing out the comment. That's all, nothing more. Okay. Okay, when you go to the memory peak memory view here, and you can see the hot path here. Let's zoom a bit. So you can see that our view is being called, the render is being called again. And what you can see here is Django DB models base from DB is called. And this is actually the function, I'm sorry, this one here, Django DB models base comment in it. So this is the initial constructor of our model. And you can clearly see that, by the way, from the color of this box here, you can clearly see that it's exclusively, this function is allocating some memory. So the lighter boxes are exclusive, and the darker boxes are exclusive. Sorry, the lighter ones are inclusive, and the darkest ones are exclusive. So this function here is allocating some memory, which is the comment itself, right? So let's assume that it's currently 200 kilobytes, but let's assume that we would like to improve that, and we already have that kind of functionality built in inside the Django ORM, which is the iterator method. So once you use iterator, you say that, okay, I will only use this once. I will only print out this comment once, nothing more. So just use a generator, return me a generator, and I will traverse it. So it will not cache your, it will not use internal caching of the query set API. So if we again profile that, and okay, you can clearly see that we have a gain here, right? The peak memory is decreased a much. So assume that it has 100 megabytes. It's peaking memory on 100 megabytes, and with a sudden just line of change, you decrease it half of the time. So by the way, I'd like to mention that this memory profiler is actually under the hood, is very similar to tracemalloc, but it's just it's just optimized for our use case. Our use case is just profiling a specific HTTP request, right? To do that, we only when you enable the HTTP header, we only trace memory allocations from the thread that enabled the probe, that the agent for Blackfire. So that means that concurrent requests allocations are not shown here. You only see the request that started the memory profiler. So this number here is actually the number that really been allocated inside your request, inside your view. And it's showing the peak memory, by the way. And yeah, and one last thing is about all these Blackfire thing is, I really use this tool, apart from the fact that this is a performance, obviously performance tool, I really sometimes use it to debug the frameworks. For example, I have used it to debug some issues in Django server, and it really helped me a lot to understand what's happening under the hood because of this hot paths, cold paths, and inclusive times. So most of the time in these hot paths, you will see the most important functions, and because they are the most time-consuming ones, they are the most important functions inside that framework too. So it really helps debugging a lot for me, actually. And I think that's all from my side. Is there anything you'd like to add, guys?
Yeah,
Well,
maybe. Oh, sorry.
No, please go on.
Okay. Yeah. I just wanted to emphasize something that Sumer has said, but it's always great to hear it several times because we often get the question. And what Sumer has presented you here with Blackfire is really a profiling tool. So it's a tool for having a developer who's going to go and start measuring how the code behaves and how it consumes resources. Sumer has explained the difference between sampling and tracing profilers. We often get also the question of what's the difference between, say, Blackfire and New Relic, for instance. So a profiler and a monitoring tool. As Sumer has said, also the main difference is going to be that a monitoring tool is essentially taking measurements on real end user traffic, whereas a profiler like Blackfire, you're going to trigger yourself. And therefore, it's never going to impact the end user traffic. So if you measure end user traffic, you add the instrumentation of your profiler or whatever measurement tool you have on that traffic. So it's going to slow it down. Whereas Blackfire is never going to slow down the traffic for the end user. It's going to slow down, of course, a little bit the request that you're currently profiling. But we also worked on the fact that the overhead is stable enough so that actually the result you're going to get is reliable from relative perspective. So when you look at the wall time measurements, so for instance, here we see 99.7 milliseconds. Maybe in real life, the code is actually going to go a little faster than that. But what really matters is that as the overhead is stable over the request, the relation and the percentage of each node that you see on the screen, how it is responsible for the overall time consumption, this is going to be very reliable. And that's actually what you want to see. You want to understand what's the slowest bit of your code. So actually, this also leads to the fact that Blackfire, yes, it is a tool that you can use on production fully, safely with no impact for end user traffic. By the way, you probably have seen also that we anonymize the SQL queries. So if ever you get questions about GDPR and stuff like this, basically we never collect any end user data. So by nature, we're GDPR compliant. But it's also a tool that you'll be able to use on your local machine like Sumer just did, as well as in, well, basically any machine where you deploy your code. In the PHP world, our product has a little, has a couple more years of experience, and we also have built it so that it can be integrated in continuous integration and continuous deployment processes with automated testing and so on. This is something that we're working on now also to make available for Python. And last thing is that I said Blackfire is currently a profiler. It's very different from an APM, but actually we are also working now on building an APM, which we hope will be available by the end of summer for PHP. And maybe a couple of weeks or months later for Python. Final word, we cover Python, PHP, and Go, and well, maybe more in the near future.
Thank you, Christoph. We got a few questions from the attendees. The first one we got, I partially responded to during the webinar, was from Sergey, who is asking if Blackfire is available on Heroku. So let me answer this. So technically, yes, because it's already available for PHP. It's part of the build pack for PHP. However, I need to check if everything is okay For Python, I know that all components are installed by default on Heroku. So maybe you can leave me your email so I can contact you back to give you a clear answer after the webinar. I will be very happy to give you this answer. Second question: Did Blackfire does Blackfire give some clue for code optimization? So actually, yes. There are. You can see the recommendations tab on the left here. So it's probably empty here because it's very simple application. We're still working on adding new recommendations based on frameworks and best practices for all the languages. Contributions are open also for this. So yes, when you have common issues from your code, then you will get recommendations. And these recommendations are available from the first plan, which is the first paid plan, which is Profiler, not on free plans. Third one was for Kamal.
Maybe I can help on this one, if you like.
Yeah, sure.
So basically what you can do is you can, so I'm assuming that this profile worker code salary is just opening a salary worker, and it's again another Python application. So any Python application can be profiled. So we have an SDK and we have an API for manual profiling. For salary worker code, you will need to instrument your code a bit, but it has a very simple API like start and initialize, two APIs actually, and you can profile your worker code in salary with manually doing it.
So you're answering the question from Carl, right?
Yes.
About okay. So yes, you can definitely profile worker code, and usually we advise in order to trigger a profile to use signals for this. So I won't get too much into details, but this is perfectly possible using the SDK. Yes. We had another one from the global chat. From Kamal Ahmed. In order to use Blackfire from behind our firewall, do we need to add it to include lists? So yes, yes and no. The first, if you want to profile on demand, like Sumer showcased, you don't need any kind of port opening or include IP addresses because it's only outgoing stream. Since we have several components in place. The first one is the probe, which collects the data and all the measurements. And the probe is sending it to another component which is separate and lives in your network, which we call the agent. And the agent does the dirty work of aggregating everything together and pruning trivial calls and so on, and anonymizing. Then after that, the agent sends out the profile data to Blackfire servers. So what you need there is that the server on your agent lives on to access outside the internet, outside your network to be able to send all data to Blackfire servers. So I'm understanding that you're having 503. So let me, if you haven't, this is error, we can maybe discuss this. But about the second part of my answer, which was yes, you need to add it to your include list. It's when you want to run builds. So this was a subject that wasn't covered by this presentation because it was out, it went far from the scope of this webinar. But what you can do with Blackfire is always to add tests and scenarios and run them periodically to check if your application is still running as expected. So in this regard, yes, when you configure periodic builds, the scenarios are actually run on Blackfire servers. So it needs to access to your network. So then this is what is explained in the link that Christoph sends in the chat. And about your error, maybe we should discuss this on our support channel to see deeper what's going on there. And I'm pretty sure I or Sumer will be very happy to answer you. And last question we had from Ali. So is it just for Django, or can we use Blackfire for other Python web frameworks? We currently support Flask as well, right?
Yes, we currently, as of today, we currently support Django and Flask, but it's always changing. And we are also thinking about a framework, integrating a framework like FastAPI and ASCII framework, probably, but we are still discussing.
Yeah, and don't get us wrong. Actually, when we're saying that we support them, it means like out of the box with middlewares. So for Django, we have let's say native official middleware which activates the probe for you, and it's the same for Flask.
Exactly.
And we're even working, well, Sumer is working hard on providing a even better solution for for configuring Django and Flask. Well, configure the probe for Django and Flask. So maybe you want to give a word about it.
Yeah, so we are considering to actually monkey patch these frameworks at initial interpreter startup. So you will even not add any middleware at all. So all you will do is just prepend your server command, that how you execute your interpreter, prefix it with some something, and it will just work. Hopefully, I'm still working on it.
Thank you. One thing I wanted to emphasize from what Sumer said was Sumer explained that he doesn't use Blackfire only for performance issues and solving them, but also to debug. And actually, this emphasizes a very important topic with Blackfire in particular and profilers in general. This emphasizes that a profiler like Blackfire is focused on the behavior of your application. And the performance issues you may have with your application are actually a consequence of malfunctioning components in your application that you need to fix. So you can definitely use Blackfire to debug your own code or frameworks, like Sumer explained he did. And this can be very, very useful. A profiler is like for any tests you may write, like unit tests or functional tests. They are very very useful, very consistent when they run timely. I mean, they come timely. You want to validate a pull request and so on. So this is all about behavior of your application. Maybe we'll get to another webinar with having everything with the automation focused on Django or Python in general. That would be very nice. So if there is no question left, maybe one last word from Sumer or from Christophe.
For me, as a technical guy, I think I have said all the things I wanted to say. So thanks everyone for joining. That's fine. Wonderful.
And thank you everyone for attending. And this webinar has been recorded, so it will be available on YouTube in a few days, within a few days, just time to edit the video a bit. So thank you everyone for attending, and happy profiling. Bye.
Thanks. Bye-bye.
Bye, guys.